Now we start here problem number 15th. Integration of 2 sin x cos x upon 3 cos square x plus 4 sin square x. 3 cos square x plus 4 sin square x. dx. Now solution of this, let I is equal to, we call this as I, so I is equal to integration of 2 sin x cos x upon 3 cos square x plus 4 sin square x dx. Now here observe that derivative of this cos square x is 2 times cos x sin x. Also derivative of sin square x is 2 times sin x cos x. So if we take the derivative of denominator, we get numerator. So we put here denominator as a t. We use here substitution method. So we put here denominator as t. So put 3 cos square x plus 4 sin square x is equal to t. Now differentiate with respect to x. That means take d by dx on both sides. So here this 3 and derivative of x square, that is twice x, but in place of x there is cos x. So 2 times cos x into derivative of cos x into derivative of cos x plus here 4 as it is. Now derivative of sin square x, that is 2 times sin x into derivative of sin x, d by dx of sin x is equal to right hand side is dt upon dx. And now take this derivative, 3 2s are 6 cos x, and derivative of cos x is minus sin x. So here we write sin x and minus sin here. So 6 minus 6 cos x sin x plus here 4 2s are 8 sin x as it is, and derivative of sin x, that is cos x, is equal to dt by dx. Now here 6 cos x sin x and here 8 sin x cos x, this is minus and this is plus. So 8 minus 2 and cos x sin x is same here. So 8 minus 2 is 6, 8 minus 6 is 2. So we get here 2 times sin x cos x. So we get therefore 2 times sin x cos x, and now this carry dx on the left side. So dx is equal to dt, which is present in the numerator. See here, 2 times sin x cos x dx. We replace this 2 times sin x cos x dx by dt, and therefore required integral I is equal to integration of upon, here upon is 2 times cos square x plus 4 times sin square x. We replace this as t. So upon t, 1 upon t, and this 2 times sin x cos x dx is dt. And now here integration of 1 upon t dt. 1 upon t is the derivative of log of t, and therefore integration of 1 upon t is log of t plus constant of integration. And now resubstitute the value of t. Therefore I is equal to log of, what is t here? T is 3 cos square x plus 4 sin square x and plus constant of integration. This is the final solution. So in this way we have completed here 15th problem. Take here a screenshot and write in your notebook. So now next 16th problem. Problem number 16. Integration of 1 upon root x 1 upon root x plus root of x cube dx. So we have given here 16th problem as integration of 1 upon root x plus root of x cube. Now call this as I. Let I is equal to integration of 1 upon root of x plus root of x cube dx. Now this root of x cube we write it as root of x into x into x cube we write x into x into x. This x into x, it is outside the root, so x into root x. So we write like this. So we get here, this is integration of 1 upon root x plus x into root x dx, and now take here root x common. So we get I is equal to, required integral is equal to 1 upon, here take root x common. So we get 1 plus x and dx as it is. So required integral I is equal to integration of 1 upon this root x as it is 1 plus, we write this x as root of x square, root of x and square, root of x and square dx. We write this x in root of x square. This here root and square get cancelled to each other, root and square get cancelled to each other, and therefore here x as it is 1 plus x, and therefore so now we put here 1 plus root x as a t. Put here 1 plus, or only here put root x is equal to t. Root x is equal to t, and therefore differentiate this equation with respect to x. So 1 upon 2 times root x is equal to dt upon dx. Carry that dx. So we get here 1 upon 2 times root x dx. Now here we carry this 2 on the right hand side. We get 1 upon root x dx is equal to twice dt. So we get here 1 upon root x dx as twice dt, and 1 plus we put root x as t. So this required integral becomes I is equal to integration of 1 upon 1 plus, put root x as a t, so 1 plus t square, and 1 upon root x dx. 1 upon root x dx we replace it by twice dt, so it is twice dt. Now this 2 is constant, take outside the integral, so it is equal to 2 into integration of 1 upon 1 plus t square dt. And now here 1 upon 1 plus t square is the derivative of tan inverse of t. Derivative of tan inverse of t is 1 upon 1 plus t square. So take the integration of 1 upon 1 plus t square, we get here it as a tan inverse of t, and therefore integration of 1 upon 1 plus t square is tan inverse of t. So 2 times tan inverse of t plus constant of integration. This is the final solution. Only put here a t as t is here root x. T is root x. So I is equal to 2 into tan inverse of t as a root x plus constant of integration. This is the final solution. So here also take screenshot. And now we see next problem, problem number 17th. Very easy problem in problem number 17. 10x to the power 9, 10x to the power 9 plus 10 to the power x log of 10 divided by 10 to the power x plus x to the power 10 dx. So this is the 17th problem. So in the 17th problem we have to take the integration of 10x to the power 9 plus 10 to the power x into log of 10 divided by 10 to the power x plus x to the power 10. Now see here denominator, if we take the derivative of 10 to the power x, it is 10 to the power x into log of 10 which is present in the numerator. And here take the derivative of x to the power 10, it is 10 into x to the power 10 minus 1, that is 9. That is also present in the denominator. So we put this as a t. So firstly call this as I. So I is equal to integration of 10x to the power 9 plus 10 to the power x into log of 10 divided by 10 to the power x plus x to the power 10 dx. Now so put here denominator as a t. So put 10 to the power x plus x to the power 10 is equal to t. And therefore differentiate with respect to x on both sides. We get here derivative of 10 to the power x as 10 to the power x into log of 10 plus derivative of x to the power 10 as 10x to the power 10 minus 1, that is 9. On the right hand side it is dt upon dx, and that dx we carry to the left side, and so it is equal to this bracket into dx is equal to dt. And now this required integral becomes I is equal to, so I is equal to integration of, now see here numerator into dx. So this is the numerator, this bracket is numerator into dx, we replace that as a dt. So here 1 upon, here it is dt, and denominator is t, 10 to the power x plus x to the power 10, we put it as a t. So in the denominator it is t. So I is equal to integration of 1 upon t dt, and we know that 1 upon t is the derivative of log of t, and therefore integration of 1 upon t is log t. So I is equal to log of t plus constant of integration. Now lastly we put here t as, so log of 10 to the power x plus x to the power 10 plus constant of integration. This is the solution of this 17th problem. Here we may use here the corollary, that is here in the denominator function and its derivative appears in the numerator. So directly we use here corollary, that is integration of f dash of x upon f of x dx is equal to log of f of x, which is in the denominator, plus constant of integration. Now here we see the 18th problem. Integration of x to the power n minus 1. Integration of x to the power n minus 1 divided by root of 1 plus 4x to the power n. Now call this as I. So let I is equal to integration of x to the power n minus 1 divided by 1 plus 4x to the power n dx, but it is in the root. So root of 1 plus 4x to the power n. And now here observe, when we take the derivative of x to the power n, derivative of x to the power n, it is n into x to the power n minus 1, which is present in the numerator. So we put here x to the power n as a t. So it is equal to integration of or we may take here 4x to the power n as a t. So put here 4x to the power n is equal to t. And now differentiate with respect to x. So 4 as it is, derivative of x to the power n is n into x to the power n minus 1 is equal to dt upon dx. And now here carry this 4 into n to the right hand side, and therefore we get here x to the power n minus 1 into this dx is equal to this 4n becomes 1 upon 4n into dt, and therefore required integral I becomes I is equal to integration of this x to the power n minus 1 dx, x to the power n minus 1 dx, it is equal to 1 upon 4n dt, 1 upon 4n dt, and here in the numerator it is 1 divided by under root of 1 plus here t, 4xn, 4x to the power n, it is t. So integration of 1 upon under root of 1 plus t, here 4x to the power n we replace as a t, and therefore we take here its integration, we take 1 upon 4n constant outside the integral, and integration of here 1 plus t, its power is 1/2, and carry to the numerator we get here 1 plus t to the power minus 1/2 into dt. And now here we use the formula integration of x to the power n dx, that is equal to x to the power n plus 1 upon n plus 1 plus constant of integration. Using that formula we get here 1 upon 4n 1 plus t to the power minus 1/2 plus 1, that is 3 minus 1/2 plus 1, and here also minus 1/2 plus 1 and plus constant of integration. And now it is equal to, so I is equal to required integral I is equal to 1 upon 4n as it is, this 1 plus t to the power minus 1/2 plus 1 means 1 minus 1/2, that is equal to 1/2 divided by 1/2 plus constant of integration. So we write this 1/2 as 2 by 1, so it is equal to 1 upon 4n into 2 upon 1, and 1 plus t, we put here t as 4x to the power n to the power 1/2 plus constant of integration. And so these 2 ones are 2 to the 4, so it is equal to 1 upon 2n, and this power 1/2 we write in root sign 1 plus 4x to the power n plus constant of integration. This is the final solution. So let here we get I as 1 upon 2n under root of 1 plus 4x to the power n plus constant of integration. This is the final solution. So in this way here we completed totally 18 problem in question number first. The remaining problems we will see in the next video lecture. Okay, we stop here.